Now, last but not least, we have Luc Valentin, not an American in Paris, but a French in America. He has been living in the USA for more than 15 years, and he will give us the user testimonials, so he can tell us how the robots are doing in your farm.
D'accord, merci beaucoup Isabelle. Donc moi j'ai une dure tâche de suivre ces présentants qui ont présenté d'abord parce que c'est la...
I have the hard task of following the first speakers because they've done research. What I am going to talk about is more or less a practical view of what is being done in the US. It's the trade methods and so on. There is another aspect which doesn't exist in France, is large crops, as Simon Blackmore was saying. Economies of scales are very beneficial for us, very good. But then also this enables us to place more specialized people in certain places and to have less costs. I was born in Clermont-Ferrand, not very far away from here. I studied in Pierrepont, very near here. Then I went to the US for an exchange, and I haven't come back. I left 20 years ago. So I'm going to tell you about the farm with which I am collaborating. I know the mindset of the Americans and American farmers. And I will present very briefly the farm holding. In half an hour, I don't have time to give you many details, but I'll give you the main aspects. As always, we talk about environmental protection, about the hardness of the job and future solutions, automation, robotization. I'll try to find the difference between a robot and automated machine. In a way, it's like a continuous curve with more and more intelligence intervening. There we have large plains in the west of Kansas, very wide, large plains, not highly populated at all. This is a map representation of the farm holding from east to west is about 100 kilometers and north to south about 50 kilometers. If you take the small green square on the right-hand side, it represents 60 hectares, to give you an idea of the scale. Now, what are the figures? Very briefly, we have 20,000 hectares, 100 kilometers by 50 kilometers. About 15 people work there full-time with seasonal workers, particularly at harvest time. We store about 30,000 tons in the holding, so it makes it easier and more efficient to manage the logistics aspects. Rainfall 470 millimeters per year, less rain than in Provence. That means to say that it is extensive. We have variation, 0.7 per this year, for example, more next year. So to manage staff and machines is a bit of a headache. Then we buy manure near the farm. We make compost, a sort of compost. We don't add carbon or nitrogen to it. So this is part of our manure. We have very few, we use very few chemical fertilizers. We fatten 1,500 animals as well. So compared to the farm holdings here, it's enormous, but for us it's not big. So how to cope with these big surfaces? 20,000 hectares is a big figure, but more or less it's 15 kilometers by 15 kilometers. I went to Google Earth to compare with the Toulouse area. More or less is a whole agglomeration of Toulouse. That means that all the decisions we have to make are on a large scale and cannot be as precise as if we were dealing with a garden. For example, given the size of the farm, to make efficient decisions is not always easy. So in this representation is as large as the Toulouse area up to Vierzon, 250 kilometers of fields on the left, 250 on the right-hand side, plus the Toulouse agglomeration. So that means you need 4.5 hours. But with a tractor, it takes less time. So we have to remember this idea, because for us to find the robot useful, they'll have to be extremely productive on such a large surface area. What methods were used? As Simon Blackmore said, the machines have to be bigger. They are more and more costly, more and more advanced, technologically speaking. To give you an order of magnitude, these are machines that are 9 to 10 meters wide, on 12 rows. We started with 12 rows, and now we are working on 16 rows for this cutting robot. So we can go, we couldn't use this machine here. That means that with this machine we have to work many hours at the wheel before the farmers managed to sow 250 hectares for one seeder. That means that for the same productivity, you would need to sow 2,000 hectares here. So if we manage to reduce mechanization costs, it's because we cover more hectares. Then driving aids are of paramount importance. Paris wasn't made in one day, so at the beginning the machines was used to help the driver, but before it was only aid, but now it has become absolutely indispensable. Then we also try to respect the environment. The entrants we have are not so many as in France. The University of Kansas explained to us that if we do direct seeding while keeping residues, will increase our yield. So that means less operations, less actions, less tilling of the soil, but the follow-up of the soil and of the cultures has got to be more precise. During the whole spring, we follow the plots to see if we have weeds, what type of weeds, so that we can adapt the treatment according to the weeds we have. So if we have, sometimes we decide to, when we see the weeds, to wait a little bit till it's grown, so that it's easier to kill. And this is one critical aspect for me, where I see that robot application can be very useful on a large scale. We have different levels of automation. In Le Mans, they showed me painting robots, for example, not long ago. So even if the robots are not highly advanced, this is our storage facility. We have two systems. We have a drying machine and the silos. The dryer is like a robot. You have a certain amount of moisture. the moisture is measured, the temperature of the burners is measured, the speed also is measured, and according to the hygrometry of the grain that comes out, all is measured automatically rather than a person doing all this. So it's very easy for maize, but not so easy for sorghum. Another interesting aspect is that sometimes instead of wasting gas to dry the grains, we put them directly in the storage facility. And on our computer, we have a system which enables us to measure the hygrometry of the grains. We have sensors in the cells. We measure the level of grains, the amount of grain, the moisture of the ambient air, the moisture of the air above the grains, above the seeds. And according to that, we put the fans on or not. We either cool it down or we dry it more, or we make it more moist. If we can sell the maize at 15% moisture, why not?
So we are now going to have a closer look at tractors, automated tractors, been marketed for years now in the US. Here is a mapping of the cover crop test plots in 2012. And thanks to embedded technologies, we've been able to do all these because it wasn't possible beforehand. And all the research work can be conducted on the farm without adding too much work. We have the self-ripping facility, we have the different cuts according to the place. Then you have the distinction that's being made with places, plots already seeded, those that have not yet been seeded, and that helps and do savings in terms of seeds, of course. As I told you before, and we have had for 7 years now tractors. They are not fully automated. They are not real robots, but they are, let's say, semi-automated, and they are able to turn left or to turn right at the end of the row, and they know how to react, how to do a half turn, how to gain strength again, gain momentum, sorry, again, and start again working. So we've been able to improve the system. Of course, it hasn't yet been generalized by all manufacturers, but it will come. Another interesting point I wanted to raise, that spraying. Our sprayer is 30 meters wide, and late spring we use nitrogen fertilizers, and we did conduct studies with Green Tech. They sell sprayers that work along the line of an optimal band measuring the content in nitrogen, and of course this helps to have adjusted spraying. And in fact, we try to improve, to upgrade the accuracy. That's the key point. We try to upgrade the accuracy of fertilizer usage. Combined harvester now, the technology is now available. You can have a look at all the detailed specifications of these machines on the internet, you know, about their speed, about the flow they can use, how they can organize troubleshooting, etc. So self-driving is, of course, essential when sowing and when harvesting, especially due to the fact that you may have dust. When you work at night, you have a lot of dust that is being spread or scattered all over the place. But thanks to sensors, to probes, you can follow the soil, the nature of the soil. soil, maybe even rough, etc. And it helps to do a better work. Working around midnight is not what is more convenient, but at least it helps to have a friendly use of the equipment. There are other available technologies to date, especially talking about combined harvesters. You can, of course, tune your machine, your combined harvester. It can even clean the seed, and you may have greater or lesser losses at the back of the machine. So you are able to gauge your machine, your combined harvester, to have a reasonable level of loss, and you try to optimize this level to have it consistent throughout the procedure, which helps to have a better harvesting results. And some systems tuning the speed or regulating the speed are doing it in order to better adjust to this loss problem. And the combined harvester is able to slow down, to speed up according to these values that you have entered, and that make it possible to optimize, in between inverted commas, the loss level, the level of loss. These are large-scale adapted robots. These robots are rather well advanced. They are being manufactured by a startup located in India, and they are fully automated, fully autonomous, let's say. And we have large-scale fields. We do sampling every 3 or 5 hectares in our large-scale fields, to be optimal, to get optimal values and results, we should be able to sample on the same site when you repeat the sampling. And if the sampling is not properly performed, it's going to cost you hell of money without yielding the requested result. Now, when you do soil sampling, you should perform at least 12 in order to get statistically significant soil values. And of course, in order to make things better, to improve the system, we can enter all the values. We have the GPS coordinates that are being embedded, and then the machine can do the sampling. And there is an added value, since this machine can can perform automated bagging. Now let's watch this short video in order to illustrate what I've just said. Slight technical hitch. Here it is. You can see some holes, and there are some flags showing that the machine was repeating the procedure on exactly the same soil, on the same plot, sorry, on the same place and site. And as you can see, the probe is being turned upside down, and the machine will do the sampling a few meters further out, or further away. Here it is. Someone came to show this machine to me, and the people found it difficult to use to some extent, and they wanted to have 3 machines for one huge farming holding. And so you have got someone working in a building and just or outside surveying what the machine is doing And I can tell you that this machine, this type of robot, makes all the difference on huge plots, large plots, the one we have in the States, of course. Here is another robot. It's a drone, flying wing. It's something that's being used in Kansas, and this is nearly full 100% automation. We have a launching pad. The robot is going to take off and to have its own flight plan, flight route, flight path. It's able to correct, to remediate the flight path, and it can measure the nitrogen content and quantity or any other parameters. Some people use the pictures taken by the drone in order to see what is the quantity of corn or maize growing the following year, and checking the impact of these new shoots on the future yields. Could we watch a video right now? I went onto YouTube and I'm going to show them their own video. I don't think it's the right video.
Doesn't always come easy.
Le changement
Donc,
n'est pas
paysage
toujours
typiquement américain,
facile.
hein.
Typical American landscape.
But every once in a while, something comes along that makes you see things in a whole new way. It changes how you plant and how you care for crops. So you have better plant health and higher
Donc, vous pouvez
yields.
voir ici le plan de
while
vol et
saving
ainsi de
money.
suite. Et donc ensuite les cartes qui sont
So you
récupérées par
have a
l'agriculteur et
flight
donc ensuite il
path
peut faire
and
des
the
zones de
maps
prescription
that are
différentes
retrieved by the
suivant ce qu'il veut traiter ou
farmer,
ce qu'il veut
and
voir
that
sur sa
can
parcelle.
of course change
Donc, voilà.
his
Donc voilà, c'est à
activity, his
Giggle. Donc ça, c'est
action,
une boîte qui est au
and
Kansas et qui
accordingly.
apparemment vend
So
pas mal
this
de...
company is based in Kansas and sells flying wings in Kansas and in the Midwest in the States. Robots and farms in the States, they are used for large-scale cereal production. Here is a map of the US, and you can see these large-scale farms that are located in the Midwest. The more west you go, and the smaller the farming units. And of course, the use of robots is not the same in the small units. The people manufacturing agricultural equipment are able to produce what we need. Technologically speaking, excuse me, they know how to do it, but it's not enough. I mean, what they have to improve is perhaps to know how to remediate any mistake, any error, and you have heard of trials that take place in the US. They are quite common, and people are often kind of reluctant and scared of the legal aspects and hassles. Now, the product is not yet perfect, fully completed, but it's going to be improved. Yet it's not always easy to point out or to screen the problems. That means we should perhaps use and integrate more sensors, more probes onto the equipment. As I was telling you, we have huge spaces. Sometimes distances are quite long. It may take you half an hour to go and fix an equipment that is faulty because the equipment, the machine is far away. This may not happen when you have someone driving the machine. This has, of course, an impact on the final yield, on the final cost. Another solution perhaps would be to have a real army, a real battalion of small robots. I've tried to get the feedback of the farmers in the States, and they tend to say that what should be best and what would be best is a weeding, automated weeding system. Weeds are more and more weed killer resistant, so one major breakthrough would be to be able to target the weeds and to have a system, mechanical or not, to target the impacted leaf or foliage, etc. And if A plus B equals C, and if we can increase C or upgrade C, people will go for C to make it highly mathematical. Now, going back to the current situation, 1H is acting on very large plots and surface areas. We will need either highly performing, highly reliable large machines or battalions of small robots. Let's not forget that seeding windows or harvesting windows are always small, and we have to adjust. That's all I meant to say today.